Hey everyone, welcome back to another edition of The Explainer. I'm honestly so thrilled to have you here today because we're about to crack open the ultimate developer's tool belt. We're looking at two absolute foundational pillars of C programming, arrays and strings. Now, if you've ever tried to build a program that handles more than, just a couple pieces of isolated info, you already know things can get messy, fast. So today, we're going straight to the source to see exactly how C handles large data sets, structuring that information so it's actually usable. Let's just dive right in.
Okay, so picture this scenario for a second. You're building a student management system, right? And you need to record the grades for a class of, let's say, 100 students. Are you seriously going to sit there and create 100 separate, uniquely named variables, like student grade 1, student grade 2, all the way down to 100? Yeah, absolutely no way. That is a massive coding nightmare. It'd be totally impossible to maintain, ridiculously prone to errors, and frankly, it's just a fantastic way to completely lose your mind. We need a hero to step in and organize the chaos, and that is exactly where arrays and strings step up to the plate.
Okay, so here's our roadmap for today. First, arrays, organizing your data. Then, our mission, calculate class averages. Third, strings, handling text in C. Next up, mission, student name search. And finally, the final challenge, matrix math.
All right, let's kick things off with part 1, arrays, organizing your data.
So, at its absolute core, a one-dimensional array is just a sequential collection of elements, and they all have to be of the exact same type. Honestly, the best way to think about it is like a perfectly organized row of lockers in a school hallway. See, instead of having lockers scattered randomly all over the building, which, by the way, is exactly how standard individual variables are stored in memory, an array guarantees that your data is neatly lined up. It's all right next to each other, tucked under one single easy-to-use group name.
But mastering arrays means you really need to understand their life cycle, and that happens in 3 very distinct steps. First up is declaration. This is where you basically tap the C compiler on the shoulder and say, hey, this array exists, and here's the type of data it's going to hold, like integers or decimals. Step 2 is definition. That's where you're actually setting aside the specific amount of memory for it in the system. And finally, step 3 is accessing the array element itself. So actually retrieving or changing the data tucked inside one of those specific lockers we just talked about. You've got to follow this exact sequence if you want to make your data actually work for you.
Which brings us to part 2, mission, calculate class averages. Okay, let's take on our very first mission here. We need to write a C program to store the marks of multiple students in a one-dimensional array, and then calculate the class average. Think back to that opening nightmare scenario, right? Trying to manage 100 different student grades? Well, by using an array, we can group all those marks under one single variable name, let's just call it student marks, and then we can write a simple loop to calculate the exact average of the entire class. And the best part? We can do the whole shebang in just a few lines of code.
Now take a look at that column on the left labeled index. Here's a crucial quirk about C. An array doesn't start counting at 1, it actually starts at 0. So index 0 is what holds the first student's mark, 85. Index 1 holds 92, and index 2 holds 78. When we were talking about accessing array elements a minute ago, this is the secret sauce. You literally just use that index number to pull the exact student mark you need right out of the array.
Of course, to successfully calculate that average, you have to apply some programming logic to organize and manipulate your data. You might even want to implement some sorting techniques. Now you might be wondering, why sort it? Well, maybe you need to find the highest or lowest score before you calculate the average, or maybe you need to find the median. Because you've got your data neatly organized in an array, sorting algorithms can swoop in and quickly shuffle those numbers into ascending or descending order for you.
All right, moving right along to part 3, strings, handling text in C. So dealing with numbers is great and all, but what about text? This brings up a genuinely fascinating question. How do you handle text in a programming language that doesn't actually have a built-in text variable? Well, the answer is brilliant in its simplicity. A string in C is essentially just an array of characters. Literally, that's it. Unlike a lot of modern high-level languages, C doesn't have a specific string data type. Instead, it just relies on the exact same array architecture we literally just mastered. It just lines up individual characters like A, P, P, L, E sequentially in memory. So if you understand one-dimensional arrays, congratulations! You already understand the foundational mechanics of a C string.
Now, what's really interesting is when you contrast the two. Think about it.
A standard numeric array is really just a single row of numbers. But when we look at an array of strings, say an entire list of student names, we're actually looking at something just a little bit more complex. Since one single string is already an array of characters, an array of strings is essentially a list of lists. It's kind of like a giant puzzle. It takes a slightly deeper level of logic to maneuver through, which is exactly why getting a rock-solid grasp on that basic one-dimensional array first was so absolutely vital.
Okay, on to part 4. Mission: Student Name Search. Time for our next mission. We need to create a C program to store and manipulate student names using strings, and we need to perform operations, like searching for a specific student by name. Basically, we're upgrading our student management system. Not only do we have their grades stored safely in a numeric array, but now we need their actual names stored in a string array. And we need to be able to query our program to find out exactly where, say, John Doe is located in our massive stack of records.
Now, to process all this string data and retrieve info based on name searches, you actually have a secret weapon: the functions located in the string.h library. Think about it. Because strings are just arrays of characters, doing things like comparing two names letter by letter manually, yeah, that would be unbelievably tedious. But the string.h library gives you these awesome pre-built functions to search, copy, and compare strings almost effortlessly. It takes a monumental headache and makes this task completely achievable. Which brings us to part 5, the final challenge: matrix math.
All right, for our final challenge, it's time to officially move beyond the one-dimensional array. You are now being challenged to master multi-dimensional arrays. To picture this, think of a grid or a spreadsheet with rows and columns, rather than just that single line of lockers we talked about earlier. From there, your real objective is to write standalone C programs that can actually perform matrix addition and matrix multiplication. It literally takes the exact logic of index access and looping we learned for calculating class averages and squares it.
So that is the ultimate takeaway from today's explainer. You've seen firsthand how arrays completely organize chaos, how strings are really just arrays in disguise, and how manipulating this data makes massive, unwieldy datasets actually manageable. You've conquered one dimension, completely unlocking the true power of the C toolbelt. Honestly, the only question left to ask yourself as you head over to your compiler is, are you ready to conquer 2? Thank you so much for joining me on this explainer, and hey, happy coding!